Goes to negative oxygen, negative chloride goes to the positive hydrogen. Yep. Which of the following solutes will dissolve in water and why? Now, remember, like dissolve likes, and water is polar. Water is polar. So do that one for me if you would. What's that stuff called? Sodium something. Sodium sulfate, right. Sodium sulfate, will that dissolve in water?
Yes.
Correct, because ionic salts will dissolve in water, so yes. You know this one, gasoline. No. When my kids were little, they'd see when you'd be at a gas station, you see the gasoline on top of a mud puddle. Oh, look, Dad, it's a rainbow on top of the mud puddle. It's like, no, children, that's gasoline, and gasoline actually is nonpolar, and it doesn't mix with that of water. So it floats on top, and it's less dense than that of water, children.
And before you got that out, they were jumping up and down.
Oh, my kids are on medication from that. So, then, what would this one be? What do you guys think on that one?
No.
Non-polar, well, watch, go back to the slide, go back here. There it is, see that center one?
Mm-hmm.
And see, they ain't mixing, huh? So no mixing there, there you go. All right, and then, how about the last one?
Yes.
Yeah, that'll work, correct. First one, yep, that will dissolve. Ionic salts go with polar solvents. Gasoline, non-polar, not gonna work. Iodine, non-polar, not gonna work. And then hydrogen chloride, that is a polar molecule, so that will work. There you go. Very good. Look how time flies when you're having fun. Huh, class, look at that. We just polished off that section already. All right, want to do the next section or get out early?
Yep.
No. Sorry, class, I gotta
Next
stop being
section.
smart ass and stop asking you that, because you'll start walking on me, won't you? Yeah, we will get out early. All right, let's do section 2. Your electrolytes. And this is what your patient will call their electric lights. The patient will go, when you start, my electric lights are off, you go. Electrolytes, non-electrolytes. Oh, what's these things? Oh, how do they get their names? Well, with the electrolytes, so here's what we're gonna do. I don't know if you can kind of see this little, it's called electrolyte tester. All right, what do we got with this thing? We got a glass beaker, we're gonna pour some distilled water. All right, it's distilled water, doesn't have any ions in it. So distilled water, then what we're gonna do is we're gonna take this little gizmo, you got a little light bulb, and you got it hooked up to electricity, and you're plugging it. Now remember, there's no ions in that water, so it's not like tap water, it's distilled water. You have what's called the anode, anode's negative, cathode is positive. And the thing is that if you sprinkle like sodium chloride, when you sprinkle sodium chloride within that distilled water, boom, they completely split into ions. And those ions help to conduct an electric current. So your light bulb goes off and it works. Then you take the middle one, it's called hydrogen fluoride. Now some of them split up in ions and some of them don't. So yeah, the light bulb goes off, it's very dim, but it works. So some produce ions, some don't. Then you just take some sucrose, some sugar, Dump that in there. Well, this is splitting ions, so it does not conduct an electric current. So a strong electrolyte produce ions, conduct electric current. Weak, like the middle one, few ions. Non, don't produce ions. Strong electrolytes completely split into positive and negative. You conduct your electric current, and here's your equation. So in your sodium chloride, what's this S mean? Solid, right? And remember what AQ is? Aqueous. What's aqueous? Yeah, dissolved in water, right? Dissolved in water. There you go. Okay, you ready? Bless you. Do this one for me if you would. Complete each of the strong electrolytes in water. So complete each for strong electrolytes in water. All right, what do we do with this thing here? Now, strong electrolytes. Before you even start anything, strong electrolytes, they produce ions, don't they? So you know that calcium chloride's got to break up into ions. Now think way back in chapter 6. Remember you had your periodic chart and I said, oh, all right, let's figure out the charges. Remember? And you look way up on top of the periodic chart. What's the charge on sodium? +1. What's the charge on calcium? +2, etc. Remember? Okay. So you know it's going to split up in ions because it tells you a strong electrolyte. All right. So first one, you cross that off because it says it's a strong electrolyte, so it's going to split up. So I'll cross A off. Can't be A. All right. Now we're down to a 50-50 chance.
C.
What is? All right. Now we have chlorine and chloride. Don't wait. Chlorine and chloride. What is? Which is which? What's this? Chlorine or chloride? Chloride. What's this?
Chlorine.
Remember that yellowish poisonous gas? I smell bleach. Then you're dead. That'd be the last words out of your mouth. And don't go smelling this stuff. It'll kill you really quick. This is chlorine. So what's the ionic form of Cl? Right there. So it's got to be what one?
C.
Letter C. Letter C. Because see this right here? That's not the ionic form. Make believe you got your chart and I say, hey, look me up chloride. What's the charge on chloride? What you would put? Cl-1, wouldn't you? Guess what that is? How about this bottom one? Remember on the back of your periodic table? Remember those polyatomic ion things? Remember? In the polyatomic ion you had for PO4. What's charge on potassium? Guys remember? +1. Yep. And what's this PO4 stuff? What's the charge? Remember down on the back of your chart it says, oh, don't memorize those polyatomic ions. Remember?
-3.
It was PO4 -3. What was this stuff called? Remember? Phosphate. Phosphate. And that's the ionic form for PO4. All right, let's go through here. Ooh, A's looking good. It says strong electrolyte, cross off B, can't be B. And nope, can't be C because it forms a polyatomic ion. So the correct answer is A. A.
Okay. That's not.
Because of the PO4, the polyatomic ion. All right, so we got those. A weak electrolyte, they produce a few ions. So you can see here's hydrogen fluoride. Some produce ions and some do not produce ions. Non-electrolytes, they don't split up at all. They're just molecules. They don't split up, so you don't conduct an electric current. Now, with equivalents. Now, equivalent, these are disgustingly easy. The amount of electrolyte or ion that provides 1 mole of electrical charge. 1 mole of electrical charge. The charge tells you how many equivalents. It's all per 1 mole. The charge tells you, doesn't matter if it's a +1 or a -1. You do 1 equivalent. So something has a +1 charge. How many equivalents per 1 mole? 1. That's all it is. Thinking it's got to be tricked to this. Now, the amount of electrolyte or ion that provides 1 mole of electrical charge, and it doesn't matter if it's plus or minus. Doesn't matter. So calcium, what's charge on calcium? 2. How many equivalents in 1 mole? Look at the charge. 2. It doesn't matter, plus